Okay, let's discuss polynuclear aromatic hydrocarbons. This is also known as PAH. So for the polyaromatic or polynuclear aromatic hydrocarbon, it's also known sometimes as polycyclic aromatic hydrocarbon or polyaromatic hydrocarbons. So these are just organic compounds that are made up of fused aromatic ring molecules. So nagdikit-dikit silang mga benzene rings. So remember that for an aromatic compound, it should have the benzene ring. Okay, so if there are fused two or more, so these can be considered as polynuclear aromatic hydrocarbon. And the simplest is the naphthalene. Naphthalene will have two fused rings, so dalawa ang kanyang aromatic rings na magkadikit, and it will have the molecular formula of C10H8. Okay. So remember, hindi ibig sabihin na sinabi ko kanina na dalawa ang kanyang ring ay madodoble lang yung molecular formula ng isang benzene ring. Remember that ang isang benzene ring ay C6H6. So pag dalawa, hindi pwedeng C12H12. Okay? So tingnan natin kung bakit C10H8 lang siya. If we're going to draw this one, okay, so dalawang benzene ring yan. Okay, so ito yung unang benzene ring and then yung ating second benzene ring. Okay, so remember that the double bond should be alternating. Okay, so if we're going to count, this is the first carbon atom. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10. Kaya nga C10 ang kanyang molecular formula. Now, when it comes to the hydrogen, paanong naging 8 lang yan? Okay, so if we're going to satisfy the 4-bond requirement per carbon atom, so this already has 3 bonds, 1 double bond and 1 single bond. So it could only accommodate 1 hydrogen. Okay? This carbon atom could no longer accommodate any hydrogen kasi nga naka 4 bonds na siya. Okay? So this 1 tapos may double bond, so that's 3 already and another there. So 4 na yan. Okay? So yung shared carbon atom nila kung saan sila nag-fuse could no longer accommodate any hydrogen. So no hydrogen for that. This one, may isang hydrogen, another hydrogen. So this one, another hydrogen. So another fused carbon atom here. So walang hydrogen dyan. So this one will have 1 hydrogen to satisfy again the 4-bond requirement. So all in all, we're going to have 8 hydrogens. So ito, 1, 2, 3, 4, 5, 6, 7, 8. Kaya ang ating molecular formula ay C10H8 for naphthalene for the two fused aromatic rings. Okay? So hindi natin i-multiply si C6H6 ha. Dapat alam natin na nabawasan yung carbon atom kasi may common carbon atom sila kung saan sila nag-fuse at syempre yung hydrogen hindi na the carbon atoms in the the hydrogen in the carbon atoms that fuse together could no longer accommodate any hydrogen atoms because it already has 4 bonds. Okay? So, naphthalene is used, ang common yan is the naphthalene balls if you are aware or if you are familiar with the naphthalene balls or yung mothball, yung nilalagay sa mga cabinet para iwasan yung mga ipis, mga pang-drive away ng ipis yun. Okay? So, that's the component. The naphthalene is in the mothballs. Okay, so they are used usually as insecticides or pesticides. Okay, now if we're going to have 3 aromatic rings fused together, we call them anthracene. Okay, so it will have 14 carbon atoms and 10 hydrogen. So for this case, meron tayong 4 na carbon atoms na nag-fuse together that could no longer accommodate any substituent or they could no longer accommodate any hydrogen kasi nga they maximize already the 4-bond requirement. Okay, so still C14H10. Now, kapag medyo na disarrange or nabago yung arrangement ng ating connections ng ating 3 fuse strings, kasi kanina dito magkakadikit sila, no? Parang here-herela sila. So, if the third ring is written or nandun siya sa taas ng ating dalawang fuse string or the second fuse string, it will be termed as penanthrene. Okay, so penanthrene still, anthracene and penanthrene are isomers because they share the same molecular formula, C14H10, but they differ in structure. So makikita naman natin magkaiba yung kanilang structure. And of course, they differ in property. Hence, they are isomers. Okay, and if we're going to have 4 fuse rings, these groups of organic compounds are known as pyrene. Okay, so pyrene is C16H10. Okay, so may 16 carbon atoms dyan and still 10 hydrogen. Okay, so these anthracene and penanthrene are the same with naphthalene. They are used as insecticides, okay, and or pesticides. Then anthracene is also used in dyes, also for penanthrene. Ginagamit sila sa dyes, or particularly for anthracene, they are used in red dye, alizarin. Okay? Now, when it comes to the position, or kasi nga ina-number natin, no? Okay, or the locants. Now, for naphthalene, i-discuss natin. The position in the naphthalene is designed or designated rather by numbers or by Greek letters alpha or beta. Okay, so dalawang numbering system. It's either by designating the locants could either be by number or by designating them Greek letters. Okay, so for naphthalene, so mag-start pala tayo dito as carbon number 1. And that would be 2, 3, 4. And then we're going to jump 5, 6, 7, 8. Akala ko kanina 10 ang ating carbon atoms. Bakit 8 lang tong nilalagyan natin ng designations? Ulitin natin, hindi na natin kailangang lagyan yung carbon atoms or designations ng carbon atom dito sa gitna. Kasi nga, sabi ko kanina, they could no longer accommodate any substituent kahit nga hydrogen hindi sila pwedeng magkaroon kasi nga they already maximize the 4-bond requirement. So, kung position-wise lang din naman ang pag-uusapan, bakit pa natin paglalagyan ng number kung hindi rin din naman sila makaka-accommodate ng substituent? Okay, so these positions, this numbering is only assigned kasi nga para sa kanilang substituents. Okay? Pero hindi ibig sabihin na 8 lang ang carbon atom ni naphthalene. So, na-review natin kanina, ang naphthalene ay may 10 carbon atoms. Yung ina-assign kong 8 hanggang 8, 1 to 8 lang na to ay para sa carbon atoms na may substituent. Okay? So, as you could see, the numbering in the naphthalene is done clockwise. Okay? So, pag ganon. Nag-start siya dito sa second ring, going to the first ring. Is of course, skipping the two carbon atoms that fuse together. Okay? Tapos, meron din tayong sa alpha and beta. Alpha yung nasa taas, 1 and 8, and 5 and 4. And beta yung nandito naman sa sides, 2 and 3, and 7 and 6. Okay? So, ulitin natin, there are 8 numbers for the naphthalene and 2 Greek letters for the naphthalene. If we're going to assign substituents or if we're going to assign locants for the substituents. Okay, so let's have the first example. We have here the naphthalene. Okay, so the parent chain is the naphthalene. And there is NO2. Ano ba yung NO2? Nitro. So since it is attached, the nitro groups have been attached on carbon number 1 and carbon number 5 of the parent chain or of the naphthalene. So therefore, we are going to number it or name it as 1,5-dinitronaphthalene. Okay? So, the 1,5-dinitro, again, the rule is if we have the similar na substituent, you make use of numerical prefixes, di, tri, tetra para hindi uulit-ulitin. So, if we're going to use dinitro, the di prefix should always have two locants, either the same or different. But for this case, they are different, so 1, 5. Again, numbers will be separated using a comma, and words will be separated from the number using a dash. There should be no space in between the last name of the substituent and the parent chain. Okay, so dinitronaphthalene. Hindi na natin papangalanan na benzene ito ha, kasi the naphthalene is a collective name for these two fused rings. Okay, second one, we have 2-naphthol or beta-naphthol. Paano naging naphthol? The parent chain is a naphthalene, but because of the hydroxyl, okay, hindi pa natin na-discuss yung alcohol, pero pasadahan na lang din natin. If the organic compound has OH, of course, this will fall under alcohol, and they all ends with all. So instead of having a naphthalene, the suffix ALENE will be dropped and replaced with an all, so as to designate or to show that they belong to the alcohol group. Nevertheless, sa numbering wise, nasa second carbon atom siya, kaya 2-naphthol. Or, since nasa 2 siya, which belongs to the beta, it could be beta-naphthol. Sorry, dapat may H dito. Okay? And then we also have here 2,4-dinitro. Paano naging 2,4? Because on the second carbon atom and on the fourth carbon atom, it has nitro. And then 1-naphthylamine. Why naphthylamine? Because itong testing natin. Okay? The naphthalene has the priority functional group of amino NH2, kaya naging collective name niya as naphthylamine. Okay, so etong tatlong ito, the naphthalene together with the amino group is naphthylamine. The amino NH2 is located at carbon number 1, kaya meron tayong 1 dyan. Okay. Ang hindi nasama dun sa pangalan na 1-naphthylamine are the nitro, kaya ito papangalan natin ng dinitro, and they are located on the second and on the fourth carbon atom. That's why you have 2,4. Dinitro 1-naphthylamine. Okay?